Oh, hello, my name is Ajax Alexis Casarrubias Rodriguez, and today I'll be talking about the Northern Lights. Well, what exactly are they? The Northern Lights, also known as Aurora Borealis in the north and Aurora Australis in the south, are lights caused by the collision between high energy charged particles coming from the Sun and molecules in the Earth's atmosphere. They are usually seen above both magnetic poles and appear in many colors. Also, green and pink are the most commonly seen. Later, I will explain why. What causes them? Well, as I mentioned in the last before, the northern lights are caused by the collision between gaseous particles found in the Earth's atmosphere and charged particles coming from the Sun. But how does this happen in the first place, you may ask? Well, when a solar wind reaches the Earth, it carries charged particles and magnetic clouds. Uh, this, this, this too will be enough to cause a massive radiation in the surface of the Earth, and obviously that will be pretty dangerous. Actually, we wouldn't even exist, but it's thanks to the Earth's magnetic field that we are still here. Uh, this is because the Earth's magnetic field serves as a shield redirecting the material of the solar winds around the Earth. Uh, a good example will be what we see in this image. Uh, Earth is here in the middle, and it's surrounded by a magnetic field, which is the which is represented in color purple. The blue part in this case will be the impact zone, where the solar wind collides with the magnetic field, and all the golden stuff around the magnetic field is the representation of the energetic particles of the solar wind being deflected by the Earth's magnetic field. It is basically how uh, our our magnetic field protects Earth. Well, um, a solar wind, as we've seen before, is usually not enough to cause the northern lights, the northern lights. Sometimes the sun spits out large bursts of plasma. These are known as solar storms or coronal mass ejections and have a stronger effect than the standard solar wind. Um, when the solar wind carries a coronal mass ejection and collides into a planet's magnetic field, it can cause the magnetic field on the backside of the planet, as we can see in the image. Here is like the coronal mass ejection, colliding. Like here, what happens is like kind of the pressure of the coronal mass ejections causes the backside of the magnetic field to press together. Uh, Charged particles then stream back towards the planet magnetic poles. Uh, the planet magnetic poles are kind of the weaker spot of the shield, if we put it that way. Uh, that's the reason of why the northern lights are usually in the northern poles. I mean, in the north and south poles, as the poles are like the weak points of the electric field. And this causes the beautiful displays, which we know as northern lights. So, although some planets or bodies, like the Earth, are shielded by strong magnetic fields like ours, others lack that protections or are weaker or even stronger than Earth's magnetic field. Uh, a good example of a non-existent magnetic field will be the Moon, which receives the full impact of the solar winds. Um, Another good example of a weaker magnetic field will be Mercury, which is the closest planet to the Sun. Uh, it Mercury do have a magnetic field, which protects it from the standard solar winds. But if a more powerful outburst, such as a coronal mass ejection, collides with Mercury, Mercury receives it in full force. Because imagine if 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 the coronal mass ejection can go even a little through the Earth's magnetic field, imagine how will it even be possible for Mercury, which has a almost 100 times weaker electric field than Earth, to defend itself against such a powerful outburst? Well, as we can see in this image, all the planets have different magnetic fields. The difference in the magnetic field of each planet depends on the core of the planet. For example, Earth's core is partially molten, while the core in Mars is thought to be solid. I said it's thought to be solid because there's no actual proof. It's kind of a theory. Well, not theory, but well, it's not. There's no actual proof. The motion within the Earth's molten core is what produces a white magnetic field. This motion is caused because of the mass of the core and the rotation of the Earth. The Sun's magnetic field. Uh, Scientists are not certainly sure in which part of the Sun the magnetic field is created, as it could be close to the solar surface or deep inside the Sun, or even like in different layers of the Sun. Yes, but the Sun's magnetic field is responsible for a wide variety of events and interactions in the solar system, such as the auroras in Earth. Uh, we can observe in the image above. In this image, we can observe the shape of the magnetic field. Uh, the but how did we got the shape of the magnetic field? Well, that's because the magnetic field is what guides the motion of the plasma in the sun. This magnetic field is continuously changing. In here first, here the well, this first image was actually taken by NASA in 2011, while this other second image was taken in 2014. Here we can see that the electric field is like in the poles, but over here is more like chaotic. And this is like the perfect scenario to cause the solar flares and solar storms. The color. Uh, the northern lights come in different colors. The most common one is the like greenish color, yellowish greenish, which is produced by the collision with oxygen molecules. Also, red lights are also produced by oxygen molecules, but they are produced at a much higher altitude. The nitrogen, on the other hand, produces blue purplish lights. It, it also depends on the altitude. In Here in the image, uh, we can see more clearly what I'm trying to explain. Depending on the altitude is how the collision with the molecule is going to react. At the higher altitude, if an oxygen molecule collides with a high energy particle, the oxygen atom glows red. In like the middle range, if it collides with an oxygen atom, it glows green, and with nitrogen, it glows blue. And at the lower altitude, it glows pink. Basically, it all depends on the particle and in the altitude in where the collision takes place. And well, that's all. Uh, yeah, thank you very much.